In lesson 2.3, we are going to learn about probably what is considered one of the scariest topics in algebra, which is operations with fractions involving variables. And even though we're going to review many of the properties we learned in the Basic Algebra course, Unit 1, we're going to start with a step that will be very important, especially in the future when we have more complicated equations, to visualize what the problem in front of us is trying to tell us. For example, if we have 3x over 4, we can always separate the fraction from the variable. So we can write 3x over 4 as 3 over 4 times x. And 3 over 4 times x is the same as 3 over 4x. This step is not necessarily, we don't have to do it, we're not obligated to do it, but we can do it if it makes us visualize the problem better. Let's look at this other example. X to the power of 5 divided by 2, or x to the power of 5 over 2. We can also separate the fraction here. Now, it's not like the 2 is not going to have a numerator. When we don't see a written numerator, the numerator is always going to be 1. So we can write this as 1 over 2 times x to the power of 5, which then turns into 1/2 x to the power of 5, or 1 over 2x to the power of 5. So we can always do this step to help us visualize the problem in front of us. Regarding combining like terms and operations with variables, fractions involving variables at the level we have learned so far in algebra, is the same idea that we know. We're going to combine like terms in this big fraction. To combine like terms, the first thing we do is look at like terms. So terms having the same variable with the same power, like these two. Both of them have the variable of x, and both of the variables are raised to the power of 2. We know that the variable is going to get copied into the answer, and we're going to add the coefficients. We learned this in the first couple of lessons in this unit. So let's bring our calculation rectangle, and we have the coefficient of 3 over 4 plus the coefficient of 1 over 3. And this is just addition of fractions. We learned this in the Basic Algebra course in lesson 1.3. We can apply this formula, or we can do any of the methods we learned in lesson 1.3 of the Basic Algebra course. And if we add 3 over 4 plus 1 over 3, we're going to get 13 over 12. And that's the coefficient of x squared. Now we can move on to the next like terms, which are the 5x and the negative 7x over 2. Both of them have a variable of x, and both of those variables of x are to the power of 1. One more time, we know the variable just gets copied, and we merge them into 1. And then the coefficients, we need to do the operation with the coefficients. We have a positive 5 and a negative 7 over 2. Well, first things first is, if we're going to do an addition or subtraction of fractions, we need two fractions. So what do we do with the 5? We can remember that if a term does not have a denominator, we can always write 1 as its denominator. So we can write this 5 as 5 over 1, because 5 over 1 is still 5. So we can always do this technique. So we have two fractions to add up, or subtract, like in this case. So we can always divide the term that is not a fraction, we can divide it by 1, so we can make it a fraction. And now all we do is subtraction of fractions, as I learned in lesson 1.4 of Basic Algebra course. We can reproduce this equation, this formula shown on the screen, or we can go to the video of lesson 1.4 in Basic Algebra and apply the methods learned there. And if we do 5 over 1 minus 7 over 2, we're going to get positive 3 over 2. And that's the coefficient of x. Finally, the last like terms are just the constants, which is negative 11 and positive 8. We just add them. There are no variables there to worry about. So minus 11 plus 8. Remember rules of signs. The negative 11 is bigger. So this turns into negative 3. And this is our answer. This is our simplified equation after we combine like terms. Even though we had fractions, it's the same procedure we learned. We just have to apply the properties of fractions.